Hi there, it's Chem Coach Powers, and today we're going to be talking about how to write a lab report. This is the way that I have my students do lab reports in my classroom, and it should work in most cases. Every classroom has a slight different way to do things. Um, the way that I do it is basically a conglomeration of some of the things that I learned while being a research scientist, as well as what is good to get students to learn and start to emphasize as they're going through the process of becoming a scientist. So um, let's just go ahead and kick into it, and we're just going to break it down step by step, and that way you can look at it and understand it a little bit as I'm talking about it. So the first thing here is that we want to make sure that when we are writing, we are going to write in third person. Okay, now this might seem kind of strange, but we want to make sure that we write in third person, so we don't want to use first or second persons. We don't want to use I, me, we, you, us, all that kind of stuff. So it's got to be they, it. The idea here is that as scientists, we want to separate ourselves from our subject material as much as possible. We want to be as objective as possible. So writing in third person kind of helps us to objectify what it is that we're doing. And at least that's the way I've always interpreted the reasoning behind that. The other thing we want to do is we want to write in past tense. So we want to write as if this has happened in the past, even if you're writing it as instructions to help somebody else to do it. So we say things in past tense and in third person. So we want to start with the title. Now, I basically ask my students to write a title that is no longer than 13 words. Now, it might seem like a long title, but the idea here is that it wants to be descriptive. And so 13 words is actually not that many when you want to be really descriptive about what it is that you're doing. The other thing is that it should include the relationships between the variables. What things are you looking at? What two different properties are you comparing to each other? Maybe an experimental variable and the dependent variable. What's going to be changing when you do that? What is the relationship between them? Try to actually talk about that relationship. Is it a direct relationship, an inverse relationship? Maybe you can say that, maybe you can't, but try to be specific about what kind of relationship it is. Next thing is the problem or the question. Okay, so we want to make a specific, testable, measurable statement or question. Okay, and so a couple key words there are that it is testable. In scientific writing, it needs to be something where we can test the hypothesis, right? And so we want to make sure that this is a testable question that we're proposing. And then we have a purpose. Now, the purpose and the problem sometimes in different schools, different papers, they're considered the same thing. In my case, what I like to emphasize is why it is that you are doing the research for this question. Why is it important for you to do this? What's the significance to society? So, when you are talking about your purpose, I want you to think, why is it important that I'm researching this? It might be something as obscure as studying how a worm moves. But there's a reason, right? And sometimes it might just be curiosity, but there might be more to it. Maybe you're hoping to get some extra information about figuring out why that worm moves that hopefully will help society in some way. So make that connection with your purpose. The next thing is your background. Now, in your background section, you want to make sure that you are talking about concepts that are significant, and maybe these things would be something that the teacher may have given you in a pre-lab session. But you want to make sure that you're talking about what kind of stuff do I need to know digging into this problem. Like, there's got to be some background information that will help me understand what it is that I'm asking. Now, it might be something as simple as, what is the Fahrenheit temperature scale, right? Like, everybody knows that. But not necessarily. So you want to make sure you're talking about what it is that you have to come to the table with in order to understand what your question is. And those are the things that you want to talk about here in the background section. Notice that also we would like to have at least one citation from a good source, okay, here in this background information section. So we expect you to do some research. Okay, that's kind of the idea here. We want you to do some research. We want to dig in and understand a little bit about the concept before you go further into it. Okay. All right, then we tap into our hypothesis. Now, our hypothesis is, it can be formatted in a couple different ways. It can be an if, then, because format, and that's fine, but it can also, be in other formats. Basically, remember, your hypothesis is kind of like your guess that you think is going to happen. Now, I like to emphasize that your guess should have a reason with it. Okay, I really think it's important to make sure that you state the reason that you're guessing what you're guessing. It shouldn't be just some weird, obscure guess that comes out of left field. You need to have some prior knowledge or some research that have led you to guess what you're guessing. So please make sure that you include the reason in every hypothesis that you do. Make sure you include the reason as to why you're guessing that particular thing. Shouldn't just be out of left field, okay? All right, materials, list of materials you're going to use in the lab. That should be pretty self-explanatory. I like that in a list format. The procedure. Okay, now in this case, I'm asking for numbered, ordered steps. Okay, and I like them to be in steps. I don't want them to be in a paragraph format. I want it to be step by step by step, like a bulleted point format, but with numbers. Okay, and put this in your own words. Even when two students are doing the exact same thing, if they will write down the procedure in their own words, you will be amazed at how different it will sound. Each person has their own unique voice, and one of the things that I can quickly tell when two lab partners are copying each other is if I just look at the procedure and everything is written out step by step exactly the same. I do this every year in my class. I basically do some simple task and I ask everybody in the class to write down what they see me doing. And it is very, very rare to have two people have the same first couple steps. There's going to be words that are changed, and even the order of what they see and how they see them doing it is oftentimes very different. So do this in your own words, as is the rest of the entire project. You should do this whole thing in your own words. So make sure that you do this in your own words as well as every other part. Don't just copy it down. Okay, what I'm usually looking for, you'll notice that this one for me is a 7-point step, a 7-point part of your project. I would like at least 7 steps. Now, your procedure could have more. If it has fewer, you can probably break up one of those steps into a couple pieces because you probably combined them. Remember, it needs to be detailed. What you write down in the procedure needs to be something that I can repeat in exactly the same way if I were doing the same project. Okay, so make sure it's really detailed, because in science, if we get some amazing result that just astounds society, then I need to make sure that I wrote down exactly what I did so that Professor X over there can do exactly the same thing. And if I don't put down the exact details, then one small little slight detail might be changing the entire project. So it's really important that you include every single last little bitty detail, okay? Now, obviously we could go way overboard with that, and because it's a quick lab report, I'm looking for 7 steps as the minimum. So give me 7 steps as your minimum for those 7 points, okay? All right, so the next section that we're going to be talking about is your data section, okay? And your data section, you'll notice, has 2 parts to it. It has a quantitative data component and it has a qualitative data component. Now remember that quantitative has to do with numbers. And so in this case, I want to see a data table. So for your quantitative data, arrange this thing into a data table. Now you might be like, well, I could just do 3 quick, easy steps and I'd be done. Why do I need to make a table out of that? Well, it's good for you to practice organizing data in tables. And so I know it might be simpler just to put a little bulleted list of quantitative data, but I want you to put some categories on it, right? So it should have like category headers at the top, or maybe on the left-hand column. Put a category to it, and it organizes information in ways that allow us to have multiple trials and multiple things done in a quick, easy way. You may not have done multiple trials, but go ahead and put it in a table because that's what we're asking you for. And it's good practice to learn how to make data tables from data. Remember that when you are doing this data table, that you should be including significant figures if you have measurements, right? So we should have one estimated digit, okay? And that should be what you're dealing with when you have your data actually in the table. Make sure that you've included your estimated digit. So if you have a graduated cylinder that has little marks, remember you're supposed to have an estimated guess between those two marks. Include that estimated guess in there, okay? And all right, so then the qualitative data. Now this can be a bulleted list. I would prefer it be a list form. I don't want it in paragraph form. That's just my personal preference. Makes it a lot easier to see and read quickly what it is that you observed. These are things that you can smell, the things that you see that are maybe unusual or just interesting, the things that you hear perhaps, you know, the things that you incorporate with your senses. These are qualitative data points.
All right, so we want to continue to go through the analysis section now to talk a little bit about that for your lab report. Basically, the idea for the analysis section is that you are able to interpret the meaning of your data. We want that to be in your own words. So we're looking for the meaning of your data in your own words, okay? That's basically the idea behind analysis. Now, a lot of times we might give you a couple analysis questions, and so this would be a great place to address those questions, right? You could put them in sentence form. You could say, okay, blah, 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 blah. Might give you a question. You just include the question stem in your answer as you respond. Another thing for the analysis section, because this is giving meaning to what you do, is by making a graph. Okay, so a graph is a great part of an analysis. It is taking the data and putting it into a visual representation. And in order to do that, you have to analyze their data, right? And so that's kind of why a graph is a great way to show the relationship. Now you're going to show the relationship between a couple variables here, right? So choose your variables like your experimental variable versus your dependent variable and show us what the relationship is between those two. Make sure you follow the guidelines for the graphing, okay? So graphing is basically got its own set of guidelines, about 10 points. Make sure you follow those guidelines to do your graph. And then any formulas. So if you have any mathematical formulas, okay, you want to make sure to show your work and include those formulas that you had to use to come up with your answer. All right, now sometimes those are going to be prominent, sometimes you might not really have any. Okay, that's okay. But if you needed to use mathematical analysis to come up with an answer, it should be included in your analysis section. We don't need a lot of arithmetic details though, so we don't want to see your long division. Okay, just show us your basic work and how you came up with it. And if you had to do like multiple trials and do the same thing over and over again, just show us the first time and then just say, hey, these other trials got these results using the same mathematical process. All right, remember to include the units. Okay, every measurement and conversion factor must have units. Don't forget your units in your analysis section. You've got to have units. Okay, otherwise it's just a number. So in science, we need to have units. Make sure you include them. And then you can also include a percent error. Now this is only if appropriate. This is if we've given you a theoretical value. If we didn't give you a theoretical value, then you don't need to calculate percent error. And so if we said, hey, you should have gotten this much of your, precipitate, and that would be the expected amount, that's your the theoretical value, then you would use that to figure out your percent error. Okay, but a lot of times that doesn't come into play. All right, then we come to our conclusion. So if you look at the conclusion here, we want this in complete sentences, and you're going to get some points for writing clarity. All right, 2 points given for writing clarity, and this is where your first and second person should not be included, otherwise you're going to lose some of these points. Okay, but what we want to see for my conclusions, I've broken it up into PCERE. All right, so I've added an E to it compared to some of the other classes at school. You might not have that extra E at the end, but I think that extra E is important. So the first thing you're going to start with is your purpose. Okay, in your own words, restate the purpose. What is the whole idea behind what you're doing here for this particular lab? Use a complete sentence. And again, when we talk about purpose versus problem, in this case, what we're looking for is not why it is that you're doing it, but what is the question that you're answering. So in a lot of ways, this should probably tie in a little bit more as a problem. Okay, then make your claim. All right, so the claim is the C of PCER, and what we're looking for is whether or not your hypothesis was accepted or rejected within a 10% value if you have quantitative data. Okay, and so if you got within 10%, if it's quantitative data, we're going to say, hey, we accept our hypothesis, we were correct. Except you won't use we, right? Make sure that you frame your wording using the independent and dependent variables. Okay, so the mass was blah blah blah. Okay, so talk about the variables in terms of what their actual values are. And if you did not have a hypothesis, then talk about whether or not you met your purpose and or your problem. All right, then our next one is evidence. Now, there are more details to each of these in the part a little bit below. Okay, so we're going to hit that here in a second, but this is the basics behind the conclusion, and we're going to hit the fine details in the rubric here in a second. All right, so our evidence. We need to show whether or not our claim was supported by the data we collected, right? And so you want to have data in the form of observations or calculations that support the claim specifically, okay? I don't need a list of data, but I want to see your analysis that shows, yes, look, our claim is actually supported. And then we have reasoning, and this one is a 5-point part. Inside your reasoning, we want to see a justification that shows why the evidence actually does support the claim. Okay, so justification is one of the key words here. All right, so you need to really connect the dots for us. Make sure that we can see that you understand how those dots are connected between your evidence and your claim. Okay, it also should connect to relevant scientific concepts or principles with an explanation. So this is the part where you want to make sure to have some connection to your prior knowledge that really supports this, or maybe you did some research. Connect that research. If it helps us to understand why these two things are connected, that's reasoning, right? Then that's where we want to see this. And then you're going to provide that source of error. Now, this could be methodological and procedural. Okay, basically we're trying to say those two are the same. Some sort of error in your procedure, okay, or in your methodology of doing the experiment. We want to see one of those. We all make mistakes at some point. We're all going to have some sort of error. I want you to figure out what your error was. And, okay, big and here, we need to include both, and your source of experimental error. Okay, so we need to include both of these things, both your methodological and or procedural error and your experimental error. So a methodological or procedural error would be something where, when I set up the lab, I maybe did not account for something that I should have. Maybe I didn't make the procedure correct. Okay, maybe you're the one that set up the lab, and so you should have changed something. So that is a methodological error or procedural error, where when you come up with the actual procedure, there was a step that you probably should have written in that you didn't write in, and it would have made things a little more clear, would have made things a little better. Your experimental error is where you screwed up in the actual experiment. Okay. So for instance, not correctly accounting for a variable while doing the experiment. And then the other part then is that you're going to include in here an explanation of how those errors would be fixed in a future experiment. Okay, so make sure to include how you would make this better next time if you had to do it over again. All right, so let's go down to our reference sheet. This is a rubric that you guys would use, and this is a peer feedback rubric. And so you can see we have basically the things that we were looking for, right? Title, problem or question. And each of these has a value for points, right? Purpose. And again, there's a difference between problem and purpose, right? Problem is the question being answered by your hypothesis. The purpose is, why is this significant to the society at large? Okay, why are scientists addressing this? Your background with your prior knowledge and or researched information, your hypothesis, a testable guess, your procedure, step by step. I want at least 7 steps minimum, right? Your data. We need to see a data table. We need to see the qualitative listed bullet points as well, okay? Analysis. And this is where you're going to have that meaning, explaining the meaning. You see that there's a point value there for graphing, and there's a point value there for work that's being shown, like did you show your work for your math? Both of those things are included, and you can see how the points kind of break down as well, and percent error, all that kind of stuff. And then here we have the exemplar. Okay, exemplar. So this is the example that I would have you look at for the conclusion part only, the PCERE part only. Okay, you can see purpose, claim, evidence, reasoning, error. Notice that this is about a page, single space on its own. That's kind of the expectation for this conclusion. Now, some labs might be a little easier than others, might not take as much time. But this one is just on this is a simple lab where we're just looking at intermolecular forces. How many drops of particular substance could fit on the end of a penny? All right, and you can see all of this stuff here. You can see that it is pretty extensive, all right? And notice that error part is pretty extensive. So let's see if we can kind of identify some of the parts. Okay, so the purpose of the lab, why are we doing it, and or what's the problem in this case, right? Determine the effect of the strength of a liquid's intermolecular forces on its surface tension. What question are we asking? If I change a liquid that has a different intermolecular force, will it change the surface tension? Okay, that's the problem we're trying to address. That's the question. This is not the purpose as distinguished from the problem, which the purpose is like, why does this matter to society, right? Why do we care if I'm dropping water on a penny, right? That would be the purpose that you would address up in the previous section. But for the conclusion, our purpose is more like the problem, okay? Then we have our claim. Notice that the claim has a hypothesis, and notice that it states the hypothesis stated that, okay? It doesn't say I thought that, all right? No first person. Notice that we have a couple things here. We have a reasoning. Would hold more water because your claim with your hypothesis should have a because or an if then. You know, the if part is going to be kind of like the because. And make sure you include that. Notice also that I made a statement that says, hey, guess what? The hypothesis was supported. We want to say whether or not our claim was answered. Okay, do we support our hypothesis? And it goes on to the next one. Evidence. Let's go on to there. Yeah, let's talk about the number of drops, right? That's basically the evidence. Now, in your conclusion, it doesn't have a data table, but if I were writing this whole lab report out, I would have a data table showing 37 drops for one, 9 drops for another, that kind of thing, all right? And notice that I also have qualitative data in here. Can you recognize the qualitative data? Can you find it? The liquids, here's some. The liquids were all clear, so the reflection of the light on the bubbles were similar. Oh, that's great qualitative data, right? I'm observing something with my eyes, the visual part. But remember, we need to have 2 of them, right? Can you find another one? Viscosity was very low. Oh, okay. Viscosity, remember, is how thick something is, how it flows. And so they're saying, hey, viscosity was very low. And they talk about that a little bit more in detail. It practically dripped out of the pipette. Okay, so they're trying to explain the viscosity was really low, explaining that in better detail. All right, reasoning. We got to connect it to the concepts, right? Surface tension is, and so we talk about surface tension. This is the main concept that we should understand in order to understand this lab. So when reasoning, we got to connect it to our background data, to our prior information that we know, to research. And so let's define surface tension in this case. Okay, here goes defines that, and then talks about intermolecular forces, right? So here's some more data. We define intermolecular forces, okay? And then we go on and talk a little bit more about hydrogen bonding and London dispersion forces, right? So giving us all this information that's going to help us understand what's happening. That's the idea here behind reasoning. And then error. Remember, we have to have a source of methodological error, how to fix it, and a source of experimental error. So notice how we've broken this down. We have our methodological error, boom, right? And then talking about the size of the drops could not be regulated. So in the procedure, we probably should have said how to make sure that each of our drops was the same. Okay, but we didn't. So that means that there was a procedural error. We did not clarify how to make sure each drop was the same. And so that would be an error there in the methodology. And then we'd go and explains why that is something that's important and how to fix it. Look, this is how to fix it in order to account for this error. Now, you may have no idea how to account for a particular error, how to fix it. Just do your best, all right? Guess. Try to come up with something the best you can, some sort of proposal for how it might be fixed. You might be wrong, but that's okay. You got to try to guess it, okay? In this case, they're saying find a method which would actually measure the volume of the liquid dispensed instead of looking at it by drops. Okay, let's actually measure the volume of the amount that's dispensed. All right, and then an experimental error. We go in a little further. Look here. Here's our experimental error. And the experimental error, where they might have messed up. The distance of the tip of the pipette was not measured to be 1 centimeter throughout the duration. And so they said in the procedure, it said to make sure it's 1 centimeter, but they weren't measuring it, and it was like up and down and up and down and up and down. Oops, yeah, I just thought about that. It probably weren't too accurate, should have measured it. That's an experimental error. The procedure told you to do it, but you didn't do it because you weren't paying close enough attention, or you forgot, or whatever, okay? But that's an experimental error. All right, so last little thing I want to show you here is the rubric that we would use to grade your PCERE. And notice the number of points that you get for each of these, purpose being restated. And notice how we go into greater detail in each of these as well, for how many points would be available for each little section. Your appropriate claim, you've got 5 points, but that's made up of 2 points. And notice how we have, a grading system of underlining and circling and things like that. That's part of what we'll do for our peer feedback. It's a great way to identify things and see things on somebody else's paper and see if you're doing what you're supposed to do. Evidence, 4 points. Reasoning, 4 points. Error, 4 points. Writing quality, 2 points. And then when we do these as grades, we always want to try to make sure we give comments to our peers. And so we have little areas for comments in there. Those are required as well. You need to make sure you have a certain number of comments. Okay, so that's the way that I have you guys do a lab report in my class. I think this works for lots of classes. It's not going to work for some, but it's definitely going to be great for me. So this is what I want you to do when you're doing a lab report from me, and it's, I think, pretty thorough, includes most things. And if you are watching this and you don't go to the school that I teach at, you probably could just ask a teacher that you have whether or not some of these things are pertinent. Maybe they don't need as much, maybe they want more, but I think you'll find that this is a thorough way to write a good scientific lab report. Okay? Thanks so much for watching this video. I hope you have an amazing lab report. Lab reports are great ways to talk about what we've learned, and I hope you enjoy doing yours. I know it can be a lot of work, but it's a lot of fun to say, this is what I discovered. This is the research, and I figured out this concept, and it's neat to be able to put that down on paper, so I hope you enjoy that part. Okay? Bye-bye.